All right, our last day of 5.5, we're going to be focusing on the multiple uh, angle theorems, essentially the half angle theorem again, and then the product to sum or sum to product formula. So example number one we have here, I'm just going to be using this example to show us how we can use the half angle formula backwards. So yesterday we talked about using this half angle formula, cosine u over 2 equals 1 plus square root of 1 plus cosine u divided by 2. But we're going to go backwards with this now. So we see that this has the formula in it, 1 minus cosine 6x over 2. So when we go backwards, this is our angle. So it's going to be equal to, I'm using number 38 on our sheet, where it's going to be the sine of 6x over 2. And we're going to want absolute value bars around this, because we know that if it's under a square root, we can only have a positive value. We can't take the square root of a negative number. But now that we're going backwards in our formula, the square root bars go away, but we need to ensure that this stays positive because it came from the this square root function up here. So now we do 6x divided by 2, and that's going to give us 3. So the absolute value of sine of 3x. So we were able to change this angle from a 6x to a 3x. And we could then use that to potentially solve some problems. Then letter B, we have a negative in front, square root of 1 plus cosine x minus 1 over 2. So if we look at our sheet in front, our cheat sheet, number 39 says if I have under the radical 1 plus cosine of x minus 2, or x minus 1 divided by 2, then it's going to be a cosine formula. So it's going to be the cosine of that angle, x minus 1 over 2. Oops. And then again, it's going to be the absolute value bars around that. So it's just using the formula, the half angle formulas backwards to make our angle smaller, and that will help in some instances. So example number 2, we're going to find the solution to of the equation in the interval 0 to 2 pi, like it's always been 0 to 2 pi. We must have the same angle to solve equations. Here, our sine of x over 2 plus cosine x minus 1 equals 0. Those don't have the same angles. So we're going to have to get those angles to be the same. Well, using the half angle formulas, sine of x over 2 is equal to plus or minus the square root of 1 minus cosine of x over 2. And then we have plus cosine x minus 1 equals 0. So now we have our trig functions have the same angle. It's just x, is just 1x to the first power. But we've now added a radical to our equation. So we're going to have to remember how we solve radical equations. And what we need to do is get this radical by itself and then square both sides. So it's going to be plus or minus the square root of 1 minus cosine x over 2 equals, well, if I add 1 to both sides, and then subtract cosine x from both sides, we get 1 minus cosine x. The step minus cosine from both sides, add 1. So the rules for solving radical equations was once we got the radical by itself, we would then square both sides. Square both sides. This gets rid of the plus or minus and the radical, because if I square anything, it's going to be positive. So now I have 1 minus the cosine of x over 2 equals, well, 1 minus cosine x squared, we have to FOIL that out or use the shortcut. So it's going to be 1 minus 2 cosine x plus cosine squared x. And that came from, again, FOILing out 1 minus cosine x times 1 minus cosine x. But we should be able to use the shortcut at this point, so we don't have to write this out and FOIL it. All right, so now I'm going to multiply both sides by 2 to get rid of our fraction. So then we have 1 minus cosine x equals 2 minus 4 cosine x plus 2 cosine squared x. All right, so now at this point, we need to gather everything to one side. And I'm going to gather everything to the right side because I want my cosine squared to stay positive. So if we minus 1 from both sides and we add cosine x to both sides, that gives us 0 is equal to, and I'm going to rearrange this to put the cosine squared first. So 2 cosine squared x minus 3 cosine x plus 1. Because 2 minus 1 gives you 1, and negative 4 cosine x plus 1 cosine x will give us negative 3 cosine x. All right, now we have to factor this, and again, we can factor it using guess and check, or we can factor it using the grouping. A lot of the ones that we're using with trig are simple enough where I'm going to guess and check them, because we know that the last two numbers have to multiply to 1. The only way to do that is if they are both 1 and 1. So the middle term must be negative. So we know that we should have some minus signs in between them, and it's got to be a minus minus because we have to have a plus 1 at the end. So like when we FOIL this, when we multiply the last terms, it has to be a positive 1. And the only way to have that happen is if it were either both negative 1 or positive 1. And then the first term, one of them has to be 2 cosine x, and the other one has to be cosine x, because when you multiply the first two, we need 2 cosine x squared. So by reasoning yourself through this, there was only one option. There was only one option that this could have been. So now we have to set each factor equal to 0. 2 cosine x minus 1 equals 0. Cosine x minus 1 equals 0. So we get 2 cosine x equals 1. Cosine x equals 1/2. X is equal to, cosine is 1/2 at pi over 3 and at 5 pi over 3. And then over here, cosine x is equal to, 1. So x is equal to 0. So we have 3 potential solutions. Now, because we squared both sides, we might have extraneous solutions. Anytime we square both sides of an equation, we've now added additional solutions that we need to make sure aren't going to come back and give us some issues. So we're going to take those 3 angles and substitute them into the original function, not the one we got once we used the half angle formula, the original. So that gives us the sine of pi over 3 divided by 2, or times 1/2, plus the cosine of pi over 3 minus 1 equals 0. All right, so sine of pi over 3 times 1/2, so we have to do this first, which gives us pi over 6. The sine of pi over 6 is 1/2, plus the cosine of pi over 3 is also 1/2 minus 1 equals 0. And that's true. 1/2 plus 1/2 is 1, minus 1 is 0. So that solution works. Then we'll try 5 pi over 3. So the sine of 5 pi over 3 times 1/2 plus the cosine of 5 pi over 3 minus 1 equals 0. So this becomes the sine of 5 pi over 6, which is positive 1/2, plus the cosine of 5 pi over 3, which is 1/2 minus 1 equals 0. That is also true. And then our last solution to check would be sine of 0 plus cosine of 0 minus 1 equals 0. Well, I didn't do the times 1/2 for sine this time because, well, anything times 0 is going to be 0. Sine of 0 is 1. The cosine of 0 is 1. Minus 1 is 0. That checks out too. So those three solutions all work out for us. All right, and then letter B, we have the sine of x over 2 minus cosine x equals 0. So again, we're going to do the exact same thing we did over here, change that sine over 2 into plus or minus the square root of 1 minus cosine x over 2 minus cosine x equals 0. Add cosine x to both sides. So we get plus or minus the square root of 1 minus cosine x over 2 equals cosine x. Then we square both sides. When we square both sides, we get 1 minus cosine x over 2 equals cosine squared x. And then again, we're going to multiply both sides by 2. So 1 minus cosine x equals 2 cosine squared x. Well, we then need to move everything to one side, so minus 1 and add cosine x to both sides. These cancel, so 0 equals 2 cosine squared x plus cosine x minus 1. Now we have to factor this like we did in the other problem, and this one does, we might have more than one possibility that we're going to have to guess and check. So again, we're multiplying to negative 1, so that means our last two numbers had to be 1 and 1. Because we are multiplying to get negative 1, one of them has to be plus and one of them has to be minus. Then the first two terms, one of them has to be cosine x, the other one has to be 2 cosine x, so that way we can multiply and get 2 cosine squared x. But we want a positive cosine when we add our middle terms. So what that means is that we have to put the 2 cosine x here, so that when we multiply these two, we get a positive 2 cosine x, and then cosine x will go here, and we multiply that with the negative 1, and that will get us down to just a positive 1 cosine. All right, so then we need to set these equal to 0. So cosine x plus 1 equals 0. 2 cosine x minus 1 equals 0. Cosine x equals negative 1. That occurs at pi. So 2 cosine x equals positive 1. Cosine x equals 1/2. And then x is equal to pi over 3 and 5 pi over 3. So then we're going to check each of these solutions. First, we'll check pi over 3. So we have the sine of pi over 3 times 1/2, which will be pi over 6 again, minus the cosine of pi over 3 equals 0. Well, we had something similar in this problem, except it was a plus, not a minus. So sine of pi over 6 is 1/2, minus the cosine of pi over 3 is also 1/2, and we get 0. That's true. So pi over 3 works. Then the sine of 5 pi over 3 times 1/2 minus the cosine of 5 pi over 3 equals 0. Well, sine of 5 pi over 3 times 1/2 will be 5 pi over 6. Sine of 5 pi over 6 is 1/2. Minus the cosine of 5 pi over 3 is also 1/2. 1/2 minus 1/2 is 0. All right, last one, pi. So the sine of pi times 1/2, or pi over 2, minus the cosine of pi equals 0. Well, the sine of pi over 2 is 1, minus the cosine of pi is -1. That's not true. 1 minus -1 is 2, which doesn't equal 0. So pi is an extraneous solution, giving us just two solutions. All right, now on to the next page. We're going to use the product sum and sum product formulas from our sheet, formulas numbers 43 through 50. So it says write the product as a sum or difference. So I have two trig functions being multiplied, and the angles are different. So that means that it's going to use one of these formulas. So we have 3 sine 2b or beta times sine 3 beta, and that 3 in front, we can kind of just ignore that for right now. Just know at the end we're going to have to multiply everything by 3. So we're just going to write that on the outside, and if we look at our formula, this part right here is going to be the sine x part of our formula. And this part right here is going to be the sine y part of our formula. So I'm going to write that 3. Our formula says that this is equal to 1/2 times the cosine of x minus y. Well, x is going to be the angle for sine, for the first sine, and y is going to be the angle for the second one. All right, so we have the cosine of x minus y, so 2b, and I'm going to change these to x, 2x minus 3x minus cosine of x plus y, so cosine of 2x plus 3x. Close parentheses, close parentheses. So that 3 gets multiplied, so it's going to be 3 over 2 times the cosine of 2x minus 3x is negative x, minus the cosine of 2x plus 3x is 5x. Now, cosine of negative x, we can rewrite that as negative cosine of positive x using the even and odd function identities. So cosine of x minus cosine of 5x. So you see the confusing part here is just using the formulas and matching things up with the correct spots. So we want to make sure we take our time with these formulas and make sure everything gets substituted in the correct way. You know, sine x and sine 2 beta, okay, your x or your angle is 2 beta. So anytime in the formula we see that x, we substitute in 2 beta. Anytime we see y, we substitute in 3 beta. And then again, I just made the angles x to make it easier for me to write. Now, letter B, where we have actual pi radians, but the question doesn't say to simplify, it just says write as a sum or difference. So we're not going to evaluate anything. So this is a cosine. We have 4 cosine pi over 3 times sine of 5 pi over 6. So if I'm looking at that formula sheet, it's the cosine y of cosine x, which is this part right here, and times sine y, which is going to be number 46 on our sheet, cosine x times sine y. And our x is equal to the angle pi over 3, what we're taking the cosine of, and y is equal to 5 pi over 6. All right, so again, that 4 is going to hang out up front, so we have 4 times, the formula says 1/2, and then sine of x plus y, so sine of pi over 3 plus 5 pi over 6, minus the sine of x minus y, pi over 3 minus 5 pi over 6. So let's multiply 4 and 1/2 and get 2 times the sine of, well, sine of pi over 3 plus 5 pi over 6. Pi over 3 is really 2 pi over 6. Added to 5 pi over 6, that's going to be 7 pi over 6, minus the sine of pi over 3, again, is 2 pi over 6. 2 pi over 6 minus 5 pi over 6 is negative 3 pi over 6. And we're going to then reduce that. So 2 times the sine of 7 pi over 6 minus the sine of negative pi over 2. And just like in the other problem, we're going to use the even and odd functions to change sine of negative pi over 2 to negative sine of positive pi over 2. So 2 times sine of 7 pi over 6 minus negative sine of pi over 2. Because, again, we used the even and odd functions where this part right here is equal to that, but we already have a negative out in front. So it's going to be 2 times the sine of 7 pi over 6 plus sine of pi over 2. And if we were asked to evaluate that, we could, because those are angles on the unit circle, but we're not, so we're just asked to rewrite it. So example number 4, we have write the sum of or difference as a product. So we're going to be going backwards. We have sine of x plus pi over 2 plus sine of x minus pi over 2. So we have the same insides, except one is a plus, one is a minus, and we have a plus sign in between the two trig functions, and they're both sines. So I'm going to look at my formula sheet, and I'm going to look at the right side and see which formula has sine of something plus sine of that same something, except the sign in the angle has switched. So we want x plus y and then x minus y in the second part of the angle, but we want the two signs joined by a plus sign. So look at number 45, and I'm going to write it down here so you can see exactly how things are going to match up. So number 45 on our sheet says sine of x times cosine of y equals 1/2 sine of x plus y plus sine of x minus y. Okay. So hopefully you can see a little bit now how things are going to match up, where the first term is our x, and the second thing in our angle is our y. So I'm going to write this over here that in our formula we need an x and a y. X is equal to just x, and y is equal to pi over 2. Now we have to account for this pesky 1/2 in front. We don't have that right here. So what that means is that we're going to have to put a 2 in front of our answer to counteract that 1/2. So since we have what our x and y are, x is just x, and our y part is pi over 2. So we can rewrite this as sine of x times cosine of y, which is pi over 2. And like I said, to counteract that 1/2 in front, we have to put a 2 in front, and that would be our answer. So example 5, it says use a sum to product formula to find the exact value of sine of 5 pi over 4 minus sine of 3 pi over 4. So the sum to product formulas are numbers 47 through 50 on our sheet. So on that sheet, we want to find the one that has sine of something minus sine of something else, and that's number 48. Number 48 says sine of x minus sine of y equals 2 times cosine of x plus y over 2 times sine of x minus y over 2. So that's what we're going to use. And this would be, our first angle is our x, and our second angle is our y. So in our formula, it's 2 cosine of 5 pi over 4 plus 3 pi over 4, because it says x plus y over 2, times the sine of 5 pi over 4 minus 3 pi over 4, because it's x minus y over 2. So then that gives us 2 cosine of 8 pi over 4 over 2 times the sine of 2 pi over 4 over 2. So we're going to simplify this. 2 cosine of 2 pi over 2, because 8 pi over 4 is 2 pi, times the sine of pi over 2 over 2, and this is equal to 2 cosine of pi times the sine of pi over 2 divided by 2, same as multiplying by 1/4, so that's going to be pi over 4. So now we can evaluate and say, oh, the cosine of pi is -1, so equals 2 times -1, times sine of pi over 4, which is square root of 2 over 2. So we multiply that, we get -2 times the square root of 2 over 2, which is going to be negative square root of 2. And that would be our answer. Now, this is just a tool that you can use. Personally, what I would have done for this problem is just figured out what the sine of 5 pi over 4 was on the unit circle, and then sine of 3 pi over 4 on the unit circle, and then subtracted them, and we would have gotten our answer, in my opinion, a lot quicker. but this tool is useful for us when we have angles that aren't on the unit circle. So that's why I decided to do it this way, to show you the formula, but to show you the formula using angles we know already. So that's it for Chapter 5. We are finally done with it. So thanks for watching. Make sure to like and subscribe.